much as what we did yesterday. This review is, these first two questions are, you have a worksheet today. There are a few questions on that worksheet you get today, where it's just what is the sine or cosine, tangent, secant, cosecant of an angle. And all of these angles that they're giving us here, these are friendly angles when they are like pi over 3 or pi over 2 or pi over 4 or pi over 6. These are all friendly angles from your unit circle. Or if they're multiples of 30 degrees, multiples of 45, or multiples of, well, 60 really is the same as 30. So any angle where they give you a multiple of 30 or a multiple of pi over 6 or pi over 4, those are all friendly angles from your unit circle. So they all have those same ordered pairs from those unit circles, okay? So I'm going to draw this picture. 7 pi over 3 is an angle in standard position. So I've got my circle, and I'm going to draw some dots. Where's pi?
180.
180. Oh, I want to put pi, not 180. Sorry. Pi. And what do I need to divide pi into? 3. This literally says pi divided by 3. Right? Pi divided. Okay. Well, that's okay. So pi divided into 3 sections. So 1, 2, 3 on top and on bottom. And how many parts do I need? 7 parts. So there's my initial side, and I'm going to open up 1, 2, 3, 4, 5, 6, 7. Places me right here in quadrant 1. And that is the angle 7 pi over 3. That's all I need to know what the ordered pair is. Is that a bow tie or butterfly triangle?
That's a
butterfly triangle. All right, so the short leg and long leg, what is the x coordinate going to be? 1/2. What's the y coordinate? Good. So what is the sine value? Radical 3 over 2. Why? Because the sine is always the y coordinate. I just like doing cosine sine. It's alphabetical. Cosine sine. Alphabetical. X, Y. Cosine sine. Okay. Down here, cosine of negative 7 pi over 2. Again, that's a friendly angle. So I'm going to draw the angle. Where's pi? What are we dividing pi into? 2. 2 pieces on top and 2 on bottom. What does the negative tell me to do? Reverse. Block it. Everything is opposite. Okay. All right. So I have my initial side on the positive x-axis, and we're opening clockwise. So 1 pi over 2, 2, 3, 4, 5, 6, 7. Pi's over 2 puts me straight up. What's this ordered pair?
0.
What's the cosine then? It's negative 7 pi over 2? 0. Yes. Okay. So draw those angles. Know your unit circle. There you go. Example 1. Find the value of the remaining trig function using the given information. This is exactly what we did yesterday. We got more of it today. Find the value of the remaining trig functions using the given information. Not pi. Cotangent. Okay, this is conditional trig equations, meaning there's conditions that we need to satisfy. So this first one here, cotangent of some angle is 3. is really information that says the cotangent of some angle is a positive value. Here, this information, sine of that angle is less than 0, which really means that sine of the angle is negative. So we need to figure out where that is. So I'm thinking about my sines. Where is, how do you find cotangent, first of all?
X over Y.
X over Y. X over Y. Okay, so to be positive, if you divide your order pairs, which quadrants is cotangent positive in? 1 and 3. Good. So quadrants 1 and 3 is that satisfies that. And think about tangent as well. Tangent is positive in quadrants 1 and 3, where the signs match. Where is the sine value negative?
3 and 4.
3 and 4. Sine is the y coordinate. Y values are negative below the axis, so 3 and 4. So where should we draw this triangle?
Quadrant 3.
Quadrant 3 works for both. So theta's in quadrant 3. So that means that angle theta has an initial side on the positive x-axis, and it opens up and it lands here in quadrant 3. So this whole angle is theta. So theta is bigger than 180 degrees, less than 270 degrees. What do we need to do to apply our trig information here?
Drop the altitude.
Drop the altitude from anywhere on my terminal side, which creates that opposite leg of my reference triangle. So this is your reference angle between the terminal side and the x-axis. So we're always looking from right next to the origin. So cotangent, what information is that when they tell me cotangent? Adjacent and opposite. Good. Adjacent over opposite. So my adjacent side is 3. Negative 3. Good. And my opposite side is negative 1. Very good. Why?
Because it's there.
Because it's negative x values, negative y values in quadrant 3. What do we need to do next? Find the third side. I'm going to call it r. So negative 3 squared plus negative 1 squared equals the radius squared. 10, yes. And so we get radical 10 for our radius. And radical 10, that radius is always positive. Always, always. And so we can find our trig functions. So we want to know what's sine of our angle, what's the cosine of our angle, tangent of our angle, cosecant, secant, and I already know cotangent. You know cotangent, what's tangent? 1/3. Okay. So looking from our angle here, what is the sine ratio? Negative 1 over radical 10, which you would rationalize to negative radical 10 over 10. What's the cosine ratio? Which then again we would rationalize negative 3 radical 10 over 10. And then for the secant and cosecant, we're just going to flip those first ones because those are easier. So negative radical 10 over 1, which is just negative radical 10, and negative radical 10 over 3. Bless you. All right. Letter B, cosine of some angle has a negative value. So we want to know, where is cosine negative?
2 and 3.
2 and 3. Very good. Quadrants 2 and 3, cosine is negative. This is telling me that tangent of my angle is less than 0 or negative. Where is tangent negative?
2 and 3. Oh, wait, no, 2 and 4.
2 and 4. Very good. Where the signs are different. Quadrants 2 and 4. So where should we draw this one?
Quadrant.
Quadrant theta in quadrant 2. Quadrant 2 works for both. Good. So I'm going to go ahead and draw that. So again, theta, angles, always in standard position. So we're going to land in quadrant 2, terminal side, and quadrant 2, there's theta. And how can I apply my trig information here?
Drop an altitude.
Drop an altitude. Which creates my theta prime, my reference angle between the terminal side and the x-axis. And then I can apply some labels. Which labels can I use?
Adjacent over hypotenuse.
Adjacent and hypotenuse. So the adjacent should be?
-2.
And the hypotenuse is 3. And I'm going to figure out the y value here. So -2 squared plus y squared equals radius squared. It's going to be 9 minus 4, which is 5. So we get the square root of 5. And it's positive. I guess I should put the plus or minus. So you remember that x's and y's can be positive or negative. And then once you know that, sine of our angle, cosine of our angle. Oh, I already know cosine of my angle. I don't need to do that one. Tangent of the angle. Cosecant. Secant. Cotangent. They gave us cosine of my angle. What's secant? -3/2, just the reciprocal of what they gave us. Flip it. All right, so sine according to my angle would be opposite over hypotenuse, so radical 5 over 3. Cosecant, I'd flip that, it'd be 3 radical 5 over 5 once you rationalize. Tangent, opposite over adjacent, radical 5 over -2, or negative radical 5 over 2. And then if I flip it, yes, -2 radical 5 over 5. Once you rationalize. Good. I love that you can do that in your head. So good. Makes it so much faster. It's like ridiculous. I hate rationalizing. Like I said before, I promise in calculus I won't make you do it. Okay, so one more thing. So this is good, right? You good with this? Yeah. Shouldn't cosecant be negative? Sine is positive. Why would cosecant change? Okay. All right, so I do want to talk about one more thing, and this I've been waiting for. The reciprocal and quotient identities. This is the last thing I'm going to talk about and has to do with calculator stuff too. So I wanted to talk about this because this again will appear on your worksheet today, and it's good to know. So you're going to want your calculator out. All right, so I have an angle in standard position. So this is my initial side on the positive x-axis and my terminal side of my angle in standard position. And we've chosen a point on that terminal side and we have dropped an altitude, which creates this length along the bottom, which is x units. So x units to the right, and then how many units to get to the point? Y units to get to the point. Okay. And I'm just going to call our hypotenuse the radius. So we know that if I want, I've totally forgotten like what the point of this is. Sorry.
Every time I take out a math test.
Honestly.
We have talked about reciprocal functions. Hold on, I think I cannot remember what I wrote. After this test, I'm super excited because we get to start graphing, and I love graphing. It's like my favorite thing. So while I'm looking at my notes for this, which I can't remember. Yes, please talk amongst yourselves while I figure out what it is I'm trying to do here. Oh, we haven't done that either. Oh, that's interesting. Okay. Oh, here it is. Okay, yay. Okay. Okay. So we are talking about the reciprocal identities. So after we do a bunch of graphing work, we'll go into identities, and identities are very interesting. And you have to know these identities. So I'm just going to give them to you right now. We've already talked about them being reciprocals. The definition for reciprocals is usually involving a 1. So the sine of some angle is the same as 1 over the cosecant of that angle. And the reverse of that is also true, meaning we can sort of rearrange this. We could multiply the cosecant over here, and we could divide by the sine. So it turns out that the cosecant of some angle is 1 over the sine of the angle. That says cosecant. I don't know what it was I was trying to write, but cosecant. Okay. So secant of some angle is 1 over the cosine of the angle. And similarly, the cotangent of some angle would be 1 over the tangent of the angle. Why do you need to know that? Well, you need to know that for when I say, hey, what's the cosecant of 45 degrees? And you want to evaluate that. Well, you don't have a cosecant in your calculator, right? So what do you have to do to type it in your calculator? You have to use 1 over sine because we don't have that button. Does that make sense to you? This is the whole point. Okay, I couldn't remember that. So to type this in our calculator, first of all of you guys have TIs, I think. No. Oh, that's right. Okay.
I got Casio.
So first of all, you TI people, go to mode on your calculator. Go to mode on your calculator, and you can see that we have right there radians versus degrees. Yeah. What mode do we need to be in? Degrees. Why? Because it's degree symbol. That's why. Okay. What's what? Okay. All right. So we want to be in degree mode, and then to evaluate the cosecant of 45 degrees, I would have to type in my calculator 1 divided by the sine of 45. 1 divided by the sine of 45. And I get 1.414, blah-bitty, which is an approximation. Okay? You could do that on a test, say, if you wanted to get an approximate solution. That might be a good way to check. On the Casio, you have the degree. You can actually use the degree. Yeah.
No, it's option F6, F5, F1.
Then F6, F5 angle, and then degrees. Yeah. So you would have to again type in the degrees. Yeah. 1 divided by the sine of 45 degrees, and you get the same thing. So good. Okay. So it's important that you can do that. Now, I also want to talk about This is why I knew there was something really remarkable that I did for the first time. I decided I wasn't going to use these letters. I was actually going to use some numbers to prove this to you. So we're going to say this is a 3, 4, 5 triangle. Lovely Pythagorean triple there for those side lengths. So now we're going to talk about the quotient identities.
Yeah.
Quotient identities. What is a quotient?
It's the product plus division.
So it's the result and the answer to a division problem. Yes. Okay. So quotient identities come from dividing two things. So here's one quotient identity. The tangent of some angle is sine of the angle over cosine of the angle. Sine over cosine. Okay? So I'm telling you those two things are equal. But we can actually prove it pretty easily using our little 3, 4, 5 numbers. Kind of nice. So what is the tangent according to this angle here that we've got? 4 over 3. Sure. Opposite over adjacent. Good. So let's work out what happens here on the right-hand side. So let's look in the numerator. What is the sine ratio according to theta?
The opposite 4.
4 over 5. Yeah. Okay. And what is the cosine ratio according to angle theta?
3/5.
3 over 5. And so what happens? Oh, the 5s cancel out. And we're left with 4 thirds equals 4 fourths. 4 fourths. Okay, so there you go. So you can see that it proves itself pretty easily with numbers. Okay, those hypotenuses. I don't know. I've been teaching 15 years. I still don't know. The plural of hypotenuse and radius. Radiuses. Okay. So if tangent is sine over cosine, what's cotangent equivalent to? Cosine over sine. Very good. These are quotient identities that we are going to use these all the time once we get to the identities unit. And they're really, really useful. So it's really important that you memorize them properly. Cotangent has cosine on top. They both start with C. Cotangent, cosine, over sine. Tangent, I just think alphabetically tangent is closer to sine. So T is closer to S, so sine on top. I don't know. I just try and look at stuff until I have it memorized. Okay, any questions about those? So this is the thing, you'll see this today, trying to figure out how to put it into your calculator. So pay attention to that, okay? Do you have questions for me?
No.